Welcome everybody, my name is Lance Littlewood and I'm an application engineer here at MLC CAD Systems. Today we're going to talk about designing for defense and using simulation for specific applications in the defense industry. Some of the major questions I want to talk about today, I want you guys to think about, is who, when, and why. Who's going to be using these programs, the software packages, when do they need to use them, and why do they need that specific software package. So as we work through the simulation levels, right, the best place to start is going to be Simulation Express or Flow Express. These are both programs that are software packages that are free. They're included with your standard and professional licenses of SOLIDWORKS, and they're a good starting point, but they don't really have everything we need. So as we get to the more advanced levels, we're going to need SOLIDWORKS Simulation or SOLIDWORKS Flow Simulation. And we'll kind of talk about what each of these has and why we would use each one here in a minute. But I want to start with Simulation Express. If you guys have taken SOLIDWORKS Essentials training or maybe some other training, you might have learned about Simulation Express. And Simulation Express is just a very baseline simulation tool. It's simple, anybody can use it. They essentially walk you through each step, what you need to do, when you need to do it, and why. But you might be asking, like, well, who does this really work for? Who needs this tool? Well, I think the best application for this tool is engineers who don't really do simulation work. They're pretty heavily involved in the design process. And early on, you want to make sure that you're not wasting time. So everything you're designing should be validated initially. So that way, we don't get too far down the road and realize that we made a crucial error early on in our design. So let's take a look and see what Simulation Express looks like in SOLIDWORKS. So we've got this wheel here in SOLIDWORKS, and let's just think this is like the wheel on a submarine door, maybe on a ship door, right? And so what we want to do here is just work through the Simulation Express tools and see what this looks like. So we'll just go to Tools, Express Products, Simulation Express. Now, so it's going to start walking me through over here on this right hand side. So this is kind of what we're going to pay attention to on the right hand side now. So I've already ran one, so I'm going to click Start Over. But this is what it looks like as a brand new simulation, right? And so what we're going to do, first thing we're going to need is to add a fixture. Now we're pretty limited on the types of fixtures we can apply. We can basically just apply a completely fixed fixture, right? Fixed geometry, and it's not going to be able to move at all. So I'm going to select the inside faces of this threaded hole on the back side. Hit my green check mark, and I'm going to go and hit Next. Now I have two options here on loads, force or pressure. I'm going to add a force. I'm going to select this hole. Then I can actually change my direction so that it is normal to say my right plane. Want this to be, set my force to be 3,000 pounds. Hit my green check mark. I'll hit Next. Make sure to specify material. In this instance, we're just going to choose a copper alloy, which is aluminum bronze. At this point, I don't have anything else to control, right? I don't have any mesh control, nothing else. I just have fixtures, forces, material. When I hit Run Simulation, it's automatically going to mesh this whole thing for me. It'll crunch through and it will go ahead and show me my results. So it's going to ask me, hey, does this deform as I expected? It looks like it does. And so here's where I actually get a few options, right? So I get my results. I've got stress, displacement, deformation, and its factor of safety. So real quick gut check, say, well, this needs to be at least a safety factor of 3. I can clearly see that this is not a safety factor of 3. So I could just go back in here to my model, edit my material, maybe make these spokes a little thicker, and then rerun my study and validate everything I've been doing. That way I'm at least on the right path to start off this project. So that's SimExpress, but what if we need more? This is where SOLIDWORKS Simulation actually comes in. So there's a few different levels of SOLIDWORKS Simulation, but just know if you have a SOLIDWORKS Premium license, you actually get the base SOLIDWORKS Simulation license included. This also allows us to run multiple parts or assemblies. We have more control over our mesh, which if you guys have any experience in simulation, you know that's absolutely crucial. The more mesh control we have, the easier it is to make sure we're not getting singularities in our stress, we're not getting inaccurate results, and we can actually make sure things solve faster and more accurately by using mesh types like solids and beams, or shells and beams, I should say. We also have way more options for our load types. Instead of just forces and pressures, we can do nonlinear material analysis. We can put in random vibration loads. We can do thermal. There's a ton of options. Here's what those licenses kind of look like, right? We can see on the left-hand side if we've got SOLIDWORKS Premium CAD license. We get static analysis for assemblies and motion. But Simulation Professional, which is its standalone simulation license, kind of has everything most people need, right? This is where you're going to spend most of your time if you're going to do buckling or thermal analysis, even optimization. One of my favorites in the bottom right in the light blue is submodeling. Submodeling allows us to run an analysis of a very large assembly, and we can run a pretty coarse mesh so it doesn't take too long. And then if we find any areas of concern, we can actually kind of just cut that section out, run it as its own analysis. We can refine the mesh, do whatever we need to do, but it's going to take all of the displacement inputs on the edges of this cut material, and it's going to, from the large assembly, it's going to apply them to the submodel. So we still get accurate deflections, but now since we have a much finer mesh, we can get much more accurate stress results without having to wait hours or days sometimes to get an accurate stress. So let's take a look at SOLIDWORKS Simulation in SOLIDWORKS and see how that will help us design some better parts for the defense industry. Alright, so we've got an analysis already set up here in SOLIDWORKS. It's actually going to be combining both a thermal analysis, or we've applied a temperature. We've then derived the stress from that thermal analysis, right? You know, if you got parts expanding, it can cause a stress. And then we're going to take this static pressure analysis. So we've got a pressure, right, on certain faces of this part. Whenever we run this, running this study will then give us a pressure result, right? So we'll have a stress from our pressure, a stress from our thermal analysis. Now, we're going to take both of these and we're going to apply them in a fatigue study. Now, you may have not ever done this before, but it's a super useful tool whenever you have stuff experiencing high cycle loading and maybe multiple different types of loads, like what we've got here, both a thermal and a fatigue study, or a thermal and a pressure load. So now that we've got our results from the static pressure analysis, we can actually take those and we can create a new study called a fatigue study. Now we've got a few different options here to define our fatigue study type. we're just going to choose the constant amplitude. And now we can come in here and start defining our load types. So we're going to add an event. This is going to be the thermal stress. And we want to cycle this 2 million times. Using a zero-based load. Let's add the other event. This other event is going to be the pressure, and we're going to cycle this 1.9 million times. Notice we've got different load ratios and different load types for each of these. And I'll make sure to choose static pressure. Awesome. So we've got all that selected. So when we run this study, it's going to calculate damage, right? So it's giving us a damage percentage. So the best thing to set the damage percentage at is just going to be 100%, right? So essentially, has this part reached 100% of its fatigue life? Now, we're going to ignore this hotspot around the bolt. That's kind of expected. Plus, we've got some contacts due to the way the bolt's set up that we can assume this is a false stress. What we can't necessarily assume is a false stress is this stress right here in the fillet area. So this is basically telling us this plot has taken our thermal load, has taken our pressure load, it's combined them, and it's applied them millions of times, and is now telling us if we're going to have any failures due to fatigue. And at this point, it looks like we are going to have, or we're very close to having a failure due to fatigue on the fillet. So this is a great application for using this fatigue study because we have multiple loads going on here. It's a little bit more of a complex situation. So we've talked about SOLIDWORKS Sim Express and SOLIDWORKS Simulation. Let's talk about SOLIDWORKS Flow a little bit. So everything we've talked up to this point has been FEA, finite element analysis or structural analysis to some degree of parts. But I know in the DoD sector, there's a lot of fluid flow analysis, whether it's parts on planes themselves, missiles, projectiles, anything going through the air, or sometimes it's really just you need to make sure that the engine bay on a certain vehicle is going to cool appropriately, right? So there's tons of applications for flow simulation. This has more accurate thermal capabilities in some situations than what the SOLIDWORKS simulation can do, because this allows for airflow, convection, conduction, all that stuff. Additionally, we can actually pull results from FEA simulation. Say we do have movement or a thermal load of a part. We can actually pull that into our flow simulation, and we can use that to aid our analysis and get more accurate results. We do internal, external flow, parts or assemblies. And what I actually want to show you guys today is using supersonic flow. And we can kind of take a look at what these flow sim licenses include, right? All types of different things, even all the way down to specialized electronic cooling or HVAC applications. Electronic cooling will probably be more useful to you guys, especially with all the electronics that are going to be on any type of equipment. And so this is going to allow you to run a way more accurate analysis. And oftentimes these are thermal based, but sometimes it is just purely fluid flow based, like in this supersonic flow. So let's take a look at how we can use this and why it would be beneficial to us. Alright, so for our supersonic flow analysis, I've got a 155 millimeter projectile. This is often or very similar to what's shot out of a howitzer. And so I thought I would show you guys just how easy it is to set up a supersonic flow analysis and see what the airflow looks like around this projectile. It's just a little bit different analysis, but this would translate also onto like wingtips of a plane. You could see if you're getting supersonic flow or maybe vortices around wingtips. You can talk about like efficiency of those edges, and so here we're going to just see how kind of efficient this this projectile is going through the air. So first thing I'm going to do is turn on my flow simulation add-in. Once I get this turned on, we're actually just going to walk through the setup process for this, and honestly it's relatively straightforward. So we'll go to our flow sim tab, we'll go to our wizard tool, and this is going to allow us to create a project, and it's kind of going to walk us through all the steps needed. So the first thing we're going to do is define the units. We're going to leave this in SI units. All we're going to be interested in here is fluid flow, and we're going to run it as an external analysis. Only gas we're going to be running today is air, right? So this is our main fluid. And we're going to turn on this high Mach number flow variable since we're doing a supersonic analysis. We'll leave our default settings for adiabatic walls. And I'm going to go in here and just verify that all of this looks correct. So temperature, let's jack this up since it's going to be flying pretty fast. And we're going to have this going at 1.7. Now I actually need to change my velocity to a Mach number. And now we've got a negative 1.7 Mach for our airflow around this. And it's going to be traveling in the negative Y direction. At this point we can hit finish. And what's interesting is, our computational domain has been modified. Maybe I'll change this to be like 1 meter in each direction. I think 1 meter is probably enough for us to see the airflow. So now we've got our kind of cube. Maybe I need to lengthen that just a little bit upwards. So let's go in the Y direction. Maybe just make that 2. Cool. So now I've got our computational domain, and there's not really a whole lot left to set up for this. We're just going to come up here and we're going to select run. This is going to take a minute, and so we'll let this run. Okay, now that that's done solving, let's take a look at the results. We can throw in some cut plots. Maybe we want to see the pressure or the Mach number on the front plane section. If we zoom in here, we can actually see the Mach number of the airflow. Pretty interesting, right? So 1.7 is our average airflow, so anything greater than that is going to be, anything greater or less than that is going to be due to the projectile, right? So anything that's not orange. We could also throw in, maybe a pressure gradient. We can see what our pressure looks like here. Looks very similar to the Mach as far as the pattern and the airflow. So just wanted to show you guys, maybe another useful tool if you already have SOLIDWORKS Flow, or a tool that you may not know was possible as far as running supersonic flow on these in Flow Sim, right? So super cool, and honestly quite useful. I think very beneficial for you guys in the defense industry.